Solving simultaneous equations by substitution. This is when I've got two equations I have to solve at the same time. I have to find a value for x and for y, which makes both of these equations true simultaneously. Substitution is the method I'm going to show you here. Now, substitution is what you should do if you have one of the equations that says y equals or x equals, which has an expression, in other words, has an expression already for one of the variables. If you have this, think substitution. Let me show you what to do. The key here is good, neat setting out. If you don't get the setting out right, you won't figure out what you're doing, you'll forget halfway, you'll get confused, you'll make mistakes. So, this is the way I do it. Label each equation. Then, I'm going to substitute this equation, this expression for y, into the other equation. So I'm going to write what I'm doing. Substitute equation 1 into equation 2. Wherever in equation 2 I have a y, I'm going to write this expression instead. 3x plus 4y, 2x minus 1, equals 29. Now, you do need to put brackets in. Sometimes you'll get away without, but most of the time you're going to need brackets to make sure you get it right. Okay, from here on, you're just solving a linear equation. I'm going to assume you're pretty good at that. I'm going to do it quickly. 3x plus, expand the brackets, 8x minus 4 is 29. Put the x's together and put the 4 on the other side. 11x equals 33. Divide by 11, x must be 3. So now I know the point where these two equations are both true is where x equals 3. But what's y? Well, what I can do is go back to this equation, because this equation tells me how to find y. So substitute what I just found into equation 1. Y equals 2 times x minus 1. Now, I should put brackets there, but I don't have to, only because I've got a simple numeric value for x. Okay, 6 minus 1, which is 5. Now, it's always good to check. I used equation 1 to work out my value for y, but it has to be correct for equation 2 as well. So let's check the other equation. Check with equation 2. Equation 2 says 3 times 3 plus 4 times 5 must be 29. Let's check. 9 plus 20 is 29. So I know I'm right. So I write, therefore, the solution is x equals 3, y equals 5. Now, because it's x and y, and we have a convention for that, you could just as easily write the solution is 3, 5, because they're x and y. Let me show you another one. Okay, 2y minus 3x equals negative 8, and 2, no, sorry, reading the wrong line from my notes, x equals y plus 3. Okay, first step, label the equations. Second, one of my equations, equation 2 this time, was equation 1 last time, equation 2 says x equals something. So I think substitution. I'm going to substitute this expression into the other equation. Substitute equation 2 into equation 1. So Wherever I see x, I'm going to write this. 2y minus 3x, don't forget the brackets, equals negative 8. Now solve the equation. Expand the brackets. 3y minus 9 equals negative 8. Collect like terms. Negative y, negative 1y if you like, you don't need that. The 1 equals negative 8 plus 9. Negative y is positive 1, so y must be negative 1. Okay, I have a value for y. How do I find x? Oh, go back to this equation. It says x equals. So substitute what I just found into equation number 2. X equals y, negative 1, plus 3. X must be positive 2. How can I check that answer? I go back to the other equation. I used equation 2 to find what x was, so now I have to use equation 1 to check. Check equation 1. Let's have a look. 2 times negative 1 minus 3 times 2 has to be negative 8, which is negative 2, take away 6, which is indeed negative 8. Therefore, my solution is x equals 2, y equals negative 1. Or if you prefer, you could write brackets 2 or 2 comma negative 1, because it's x and y. Now, it's really important that you watch that setting out. Label the equations, explain and justify what you're doing and why, and check your work at the end. Sometimes it's going to look a bit different. Let me get another piece of paper. Sometimes your equations are going to look like this. Negative 3x plus 2, 7x minus 8. Now here, let me label them 1 and 2. Here, both of my equations have an expression for one of the variables. Just made a mess on the page. So here it doesn't matter which one I substitute. Actually, this is equal to y and this is equal to y, so these two must be the same. I actually write it slightly differently. I go 1 equals 2 because they both are equal to y. Negative 3x plus 2 equals 7x minus 8. You are still substituting. You're basically taking this expression for y and writing it where the y is on the other equation. Okay, solve the equation. Now here's a trick. If I put the 7 over this side, I'm going to end up with negative x's. But if I put the 3 over this side, I'm going to end up with positive x's. I always move the variables to the side that has more right now. Then I'll end up with positives. So this side is going to be 7x plus 3x. And this side is going to be 2 plus 8. 10x is 10, x must be 1. Now we go back and substitute. Doesn't matter which one we pick, so let's do number 1. Y equals negative 3 times 1 plus 2, which is negative, it's up here, negative 3 plus 2, which is negative 1. And then check it with the other equation. I substitute it into 1. I'm going to check with equation 2 from here. 7 times x minus 8 is 7 minus 8, which is negative 1, which is the correct value for y. I know I'm not. Therefore, the solution is, right the other way this time, 1, negative 1.